So two objects in orbit around the same body will have exactly the same value for r cubed over t squared. And it will be this value here. Now the orbital speed will be given by v equals the square root of gm on r. And of course we can get that simply from our earlier equation. So we can see that the orbital speed depends only on g, the gravitational constant, m, the mass of the central body, and r, the radius of the orbit. So that means that if we know the radius of an orbit and the mass of the central body, we can figure out exactly how fast the object is orbiting. So when our orbital velocity is greater than this figure, we will no longer follow a circular path. Instead, we're too great. A horizontal velocity, rather, is too great for a circular orbit. It means that gravity can't pull us back into a circular object because it's just not strong enough. So instead we'll follow a path like this. If we speed up over here, then that'll push us out of a circular orbit. We'll end up coming all the way out here. Of course, at a much larger radius, we'll be moving much more slowly, which means that the velocity at the right side of this orbit is much smaller than the velocity on the left side. So we'll follow an elliptical orbit, and the Earth will be at one of the foci of the orbit. Remember that an ellipse has two foci, or two focuses. One of them will be at the Earth, the other will be in empty space. In this case, when we speed up, the Earth will become the focus nearest to the satellite when it begins to speed up. All right, now let's take a look at the other situation where v is less than that variable. In this case, we'll slow down over here, and in fact, we will exit orbit by crashing into the Earth. So the horizontal velocity is too small for a circular orbit. Gravity is pulling us toward Earth more strongly than it needs to for a centripetal orbit. And that means that we move towards the Earth, right? And so once again, we have an elliptical orbit, except if we slow down at this end, then it means that the focus at which the Earth is at will be furthest away from us, instead of the focus closer to us. However, we'll still be following an elliptical orbit with the Earth at one focus. It'll just be a different focus, and that, as you can see, will make all the difference. All right, so that's the end of the theory. We've figured out how Kepler's third law applies to orbits.